Hello guys, this is me Bharati Kanan. In this video, we are going to learn linear search using JavaScript. So linear search is a searching algorithm. It is used to find the element in a given array. Let's take an example. This is the array. Let array equal to something elements. I'm going to declare some unsorted numbers here, like 9, 7, 1, 5. And then 4. This is the uncertain number. We are going to find the particular number in the array using linear search. So basically linear search follow the linear flow, which is the linear flow means it checks each and every number one by one until find the exact target number. Let's take a target number which is 5 here. We are going to find the 5 in the given array. So how can we find the number using using linear search? First of all, we need to iterate all the element one by one. In the first condition, it checks 9. Does 9 equal to 5? No, it does not equal, so it skips this. Then it move the next element. Then it checks 7 equal to 5. No, 7 does not equal to 5. Then it move the next element. Then it check 1 equal to 5. No, it does not equal. Then it checks 5 equal to 5. Yes, in this condition we get the output in the iteration of fourth iteration. This is the flow of linear search. It checks one by one. So this is the flow of linear search until they find the element. What if the element does not present in the array? It will return -1 or something, whatever we are given the log in the code. Okay, let's move on to the LeetCode to understand how linear search work in the code. So this is the problem. We are going to solve this problem using linear search. Don't confuse about the title. So the title is binary search, but we are going to solve the problem using the linear search. In the next video, we will solve the problem using binary search. So in the sake of simplicity, just look the input and output statement here. In the first example, they provide some of the inputs here. We are going to find the 9 in the array. So and also we are going to return the index of the array, not a number. We are going to return the index. Let's say calculate -1 is 0, it's 1, 2, 3 and then 4. That's why they written 4 here. What if the number does not present in the array? We are simply written -1. In this example, we are going to find the 2 here, but 2 is not present in the array. So this is the problem statement. We already see the same concept in the visual representation. Okay, let's write the code here. Initially I'm going to write the for loop here. So let I equal to 0 and the I less than how long we are going to traverse. We will traverse the whole array. So I'm simply written n here. So n means we will declare the length of the array. So n equal to nums dot length here, and I plus plus we will iterate. So I give I plus plus here. Here I'm going to check if nums of I, which is first number in the initial, is equal to target, which means if both are same, if we find the target, we will return the minus, we will return the index here, which is I here. And then if number does not present in the whole array, we will simply return the -1. This is the whole flow of linear search. And in this problem, just I format the code and then submit the code. Yes, it accepted successfully. If I submit the code, what will happen? It accepted successfully and also beats 100% of the users. So here I'm just take a screenshot to understand what is the space and time complexity of the problem. This is the background detection diagram. I just paste the problem here. So this is the solution we did here. So So for here, coming back to space complexity, we haven't used any extra spaces here. We just calculate the num only here. So it's the O of 1 space complexity. Wherever we didn't use any extra spaces, the space complexity of the problem is O of 1. And let's talk about the time complexity. So for here we use the one loop. The loop iterate the n until the n value. So we are using single loop, and the single loop is iterate the whole array. So we, in this case, the times complexity of the loop is O of n. So time complexity is O of n here in the linear search. In the next video we will talk about the binary search. In compared to linear search, the binary search is more efficient. So and also the binary search time complexity is O of log n. This is much better than O of n time complexity. We will talk about the binary search in the next video. That's all about linear search. Thank you for watching. We will see in the next video. Tata guys.